And hello, welcome to this video. In this video, I want to go through some of the server minimal code again. And in the last video, we went through a little bit more of asynchronous functions or coroutines. Okay, so we know what these bits of code actually does. Why is it there? We have a better understanding of it, even though it's a minimal understanding, very low, very beginner-ish level. Understanding of what asyncua is about. We haven't gone through complicated functions. So the next step in learning more about opcua is to figure out what's going on with this code here. What is server init, and all that. So without further ado, let's start. And I just want to refer you to some of the good documentation. Here's opcua server class under Python opcua documentation. Now, just a note. This is not actually the same. It's not actually the same module as this opcua asyncio. Okay, this is actually the Python opcua module. Okay, the GitHub repository or module. Yeah, it is. It says this library is deprecated. So this is the old version of Python opcua implementation. Okay, again, the latest version is here. It does Python 3.7 onwards. Okay, asyncio. See, it does Python 3.7 onwards. Anything below Python 3.7, this library doesn't. This module doesn't run. Okay, so that's what you need to know. Okay, I will leave all this in the description. So this library is deprecated. So it's telling you, please switch to opcua asyncio, which also has a sync wrapper with very few changes to API. What does that mean? It means that the syntax of how we create server and client or do stuff with opcua in Python using the opcua asyncio version of the code. Okay, the way we run it, the syntax and all that is very similar to this older version of the opcua. Okay, therefore, since that is the case, yeah, we can take a look at some of their documentation. Okay, the old opcua's Python documentation is very much more established. The newer one, I can't really find it as of February 2022. So for the time being, we'll just look at the old opcua server documentation in order to give us a clue as to how the new asyncua server classes actually works. Okay, so that's just some context you need to know before we continue. Alright, so yeah, let's go through the code one at a time, and also we will try to simplify the code. So what I'm going to do is just do a line by line introduction of what the code's actually doing to help us to understand the code better. Okay, and what I'm going to do is, well, I actually changed my experimental server.py. Oops. I changed my experimental server.py to delete everything except the very bare basics. Okay, so what did I delete? Okay, I deleted this UA method, and I deleted this UA method over here. I deleted the logging bits, and everything below here I deleted. So we won't put in this code unless we understand what's going on. So we will go through each of these functions and steps one at a time. And I also deleted this part. If name equals to main, then you run. All I did was, instead of that, I just have one asynchronous function defined. I import asyncio, I import system, and system path insert blah blah blah. This thing I will just leave it there. I will not explain what's going on. And I will say from asyncua import UA and server. That's all. Okay, so these are the lines of code they are there. And then under the main function or the driver function, I will just start declaring a server object. Okay, declaring server object, you don't need to use await. Okay, the object will be there. So this is object declaration. So if you need to be familiar with object-oriented programming, so I will not go through that over here. It's assumed knowledge. And what I want the code to do is to print what this server object is, and then print the type of this object. Okay, and then to run this main function, all I'm doing is asyncio run main. Okay, this is all I'm doing now. So hopefully nothing too new. Okay, so let's try to run this code. Okay, let's try to run this code. Okay, I'll have one on Vim and the other one do Python 3 experimental server.py. Okay, so what's it actually printing out? So when I start running the server, okay, when I start running the server, it will print out what this server is. It will just say opcua server, and then it will give the URL of the server. All right. Now, you may or may not understand what this means, so you need to start understanding some of computer networking. What is TCP? At least that will give you a clue as to what this is. TCP is Transmission Control Protocol. If you're not sure, again, please go and look at my YouTube series of computer networking and internet for newbies. So that'll give you an idea as to what TCP is. This is an IP version 4 address along with a port number. Again, from this video onwards, I will just assume you know what that is. So this 0.0.0.0 is actually IP version 4 address which you can ping. Okay, so if you're not sure what this is, again, please go and look at the videos or go online. I'm not going to reintroduce all of these things. And you can ping this. And basically you're pinging your own loopback address or your local host. In non-complicated terms, you are pinging yourself. So literally there's no lag here, or minimal lag, 0.0155 milliseconds, whatever. So it's very little lag. So there's nothing much going on here. So 0.0.0.0 on port number 4840, that's the default OPCUA port, I guess, and the default IP address. So this is setting up an OPCUA server with the address of the local host. That's all. And these are the default settings. All right. So server equals to server. Okay. Server equals to server with bracket. This is object declaration. So this thing is called await server init. Okay, what's await here used to do? Okay, as we learned in the last video, await is used to run a function. And this function here is called the init function, otherwise known as the constructor function. Alright, so if we take a look at the source code, you see that init is the constructor. I hope you know object-oriented programming. Or if we take a look at OPCUA's asyncio, we can actually look into their source code as well, asyncua, and then hopefully this is the init.py. Okay, from this init function actually it helps us to import some things. At least that's the way it looks. Init.py. Okay. Yeah, these are all the constructors and everything from there. I wish they had a full like source code kind of thing, but yeah. Oh, server. This one's the server. Asyncua server from .server import server. Okay. Yeah, this is server.py. Finally. Okay. This is where the server class is what do you call that? Defined. And of course you'll see some documentation here in the form of code comments. And alright, there's the old init constructor over here, but here you also have a new init. So this is kind of missing from this OPCUA server class. Over here you only have the old init function, but yeah. So when you declare a class, this init function will be run. Sorry, it should be here. This init function will be run, and look at what the init function is doing. Oh, it sets the endpoint to be this OCP, OPC, TCP, blah 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 server. That's where you get your default address from. It will give you an application URI. What is URI? URI, if you look at the internet, this is called Uniform Resource Identifier. So you can go to Wikipedia, read up more of this. Okay. And apparently URL, the one you're more familiar with, URL is apparently a subset of URI. So I'll just leave the Wikipedia link in the description. You can go and take a look at it yourself. Yeah. So you see the application URI and the product URI, all of them are given. Okay. And then the name is free opcua Python server. Manufacturer name, free opcua, and then you'll keep on defining and giving lots of pieces of data. Okay, you will just give a lot of pieces of data into this opcua object. Okay. So again, I hope you are familiar with object-oriented programming and why is this self here used over and over again. I will not explain that. However, not only that, there is also another init function, literally init without the underscores, and this is an asynchronous function. And the only way to run an asynchronous function is with the use of await. So when this await server.init is done, you are actually running. Where's the? Oops, too many tabs open. Okay, you are actually running this function. Okay, so what does it run? Init, it will have the self. It will have shelf file equals to none. So you don't really need any inputs. Okay, because the self is just the object, shelf file is none. So whatever. Yeah, you don't need any inputs. Long story short, it says what? self.iserver.init shelf file. So iServer is something else. Yeah, I wonder where iServer is. Where's the first time you define iServer? Okay. So iServer, self.iServer is iServer if is equal to iServer. If iServer, else internal server user equals user manager. So this is what the iServer thing is. Yeah, self.iServer. So this is where self.iServer is defined. And then you run the init function on this self iServer. So this iServer has to come from somewhere. Okay, this iServer has to come from somewhere. Oh, this is also called internal server. Internal server is actually over here. Okay, iServer is, internal server is actually over here, and then this internal server is none. Where does internal server come from? You actually have to import it from this .internal server. So a lot of things are going on behind the scenes. So that's where this iServer thing is coming from. And then you're using that, you're awaiting that init function, or running the init function asynchronously. Of course, based on the structure of how we actually look at our server Python file, we are actually able to see that probably this iServer thing has an init function like this as well. Okay, so I'm not going to go through this. It's just running some code behind. It's setting an application URI. Okay, and we discussed what URI is just now very briefly, and then it starts getting some nodes. UA node ID. What is this? Okay, so next time maybe we will talk about it. Okay, as of now, I'm still learning and experimenting around. What I know, I will explain. What I don't know, I'll probably maybe learn about it and maybe cover it in the next time. So these things I'm highlighting as of the time I'm making this video. I'm not sure what this is, but I'm just exploring. So SA node, await SA node. It looks like this is a coroutine itself. Okay, and is using a self.getNode function. So this is a get function that should be inside this opcua thing. So if you look at getNode, okay, where is getNode defined? Okay, where is getNode? In line 448. Okay, line 448 is get node self node ID. So based on the node ID, you really get the node. All right. So this is the node that we are getting. And remember, I said nodes are places for you, or objects for you to store smaller objects, and every object will have variables under it. So there's some sort of hierarchy. Okay. So yeah, that's the picture we have now, based on the clues that we are looking for in the code. Okay, so this is getting a node, and then of course you await. So all of these are things that are going on under the hood. You don't actually have to deal with it. You just according to the OPCUA server, you just await server init. So you're just starting out. All of the complex stuff you don't have to deal with. Okay, but in case you want to meddle with things under the hood, you can look at the source code and see what are the functions underneath, and then you execute them as and how you wish to manipulate or not manipulate, customize your OPCUA server. Alright, so await server.init actually runs this init function. Yeah, it runs this init function, and it will have something called the SA node. It will have this SA node, and it will have a SL node, and then it will write the SA node and SL node into this whatever, I don't know. Okay, and then last thing is it will also run the coroutine build self-info, product URI, manufacturer name, self name, blah 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 blah. Okay. Alright, so there's a lot of writing of data going on here. Okay, it may run other things. I have no idea what goes on under the hood. I'm not going to try to understand, because that's not the job. That's not the point of this video. We just want to understand enough to use it, but not to understand the whole code through and through. Okay, so this is server.init, and that's the function. So let's try editing. Okay, we'll try editing. So remember, server.init is a coroutine. We need to use await server.init, and then of course, if you want, you can actually print the type server.init. Okay, and then of course we can run the file. Okay, so it's a method, of course. Nothing surprising there. It's a method, of course. Yep. So if I do the extra 2 brackets here, I will declare I'm declaring a coroutine object. I'm not running it, but I'm creating a coroutine object. So it gives us something. You give us a warning saying server.init was never awaited. So all I'm doing is I'm making an object. Okay, server.init becomes an object. Okay, this class is a coroutine class. All right. So this is a server coroutine class. This is what the server init does. It's just a function you got to run first. I guess that's the way we can think about it. Okay, so what's setting the endpoint here doing? Okay, well we are giving we are giving ourselves what do you call that? A URL for our OPCUA server, so that if a client wants to connect with the server, they need to know this URL. Okay, so usually if we don't define it, the constructor will define it for us. So this is the default value. Okay, and it's under self.endpoint. So actually, if you want to get the endpoint, you can just do server.endpoint, right? Print server.endpoint. All right, so I'm going to try doing the print server.endpoint. Okay, print server.endpoint, and let's see what happens. Okay, what's the pass result? The scheme is OPC TCP. Network location is 0.0.0.0. Port number 4840. Path is free OPCUA server. Everything else you don't really deal with it, right? So this is our server endpoint. This is not a string, all right? This is not a string, but it's a URL parse. Okay, where does URL parse come from? It comes from the URL parse library. It's this specific line over here. But for our purposes, we don't really need to deal with it. We can just give a string there, because everything, all this parsing and everything is done under the hood of the server code, so you don't really need to deal with it. Okay, so yeah, so this becomes the yeah, this one I don't need to do it anymore, or rather, yeah, this one maybe I'll comment it out. This is a server endpoint, and what do we usually need to do to set the endpoint? Well, we need to do this, use the set endpoint method. Now we set endpoint. Okay, server dot set endpoint. Okay, opc.tcp. Okay, ://192.168.1.1. That's a very common IP address. Okay, I don't even know if it works. Then maybe give it a port number 4840. Free opcua and server. Free opcua server. Okay, with a / at the back. Then let's try printing the server endpoint again. Okay, so this is just me messing around with the the attributes within, and let's print the server endpoint after that. So okay, yeah, I think maybe I'm going too fast, because I kind of skipped what this init actually does. And of course I don't know what it does. I'm just like hopping over to the set endpoint thing. I was like, oh, this is the next thing in the code, and yeah, let's explore what it does. All right. Okay. Maybe I'll do. Okay. I guess for this video, I'll stop for now. But before I stop, I'll just I'll see whether this code works, because I just wanted to play around with this set endpoint function and see whether that is able to change the server endpoint. And I gave it a random IP address. I don't even know if it works. So let's try. Okay, so I'm able to change the IP address, okay, using this set endpoint function, and I print the server endpoint. Oh, we get that. Okay, that's great. I wonder if there's a get endpoint, but okay, I think that's too much data, data overload. So I'll stop for now. Yeah, thanks for watching. I'll maybe continue more exploring of this code in the next video, hopefully in a more coherent manner as well. Okay, see you.